This video starts section 4.3, and 4.3 is going to cover optimization. Basically, optimization is going to try to find the highest or lowest values attained on a certain interval. We are going to look for these highest and lowest values in situations with constraints and in word problems. Let's do an example. This example asks us to find the maximum value of v equals 2x times y to the second power, given that x plus y is equal to 72. We are going to assume that both the x and y value are positive. We're trying to find the maximum v possible. Since that we're given x plus y equals 72, that puts some constraints on x and y. So this x plus y equals 72 is often called the constraint equation. Essentially what we're going to do, since I have volume equals 2x times y squared, that has two variables in it, both an x and a y. So what I do is I use my constraint equation to substitute out one of the variables. In this case, let's subtract y from both sides. If I subtract y from both sides of the constraint equation, I end up with x equals 72 minus y. Then what I can do is I can take the equation that I'm trying to maximize, and I can substitute out my x for 72 minus y. Now I have an equation in one variable. Let's multiply that out and simplify it. V equals 2 times 72 is 144 minus 2 times y squared. Simplify it once more. V equals 144y squared minus 2y to the third. Now what I'm trying to do is find a maximum value for this v. Now, I had that x plus y equals 72. Also, we can't forget x and y are both positive. So I need to find the maximum value for y, the y that gives me the maximum value such that y is positive. In order to find a maximum, I'm going to look for the critical values by taking a derivative. That would be 288 times y minus 6y squared, and then setting that derivative equal to 0. If I take 288y minus 6y squared, set equal to 0, then I can factor the right-hand side. 0 equals y multiplied times 288 minus 6y. In my case, this means either y could be equal to 0, or when you set 288 minus 6y equal to 0, you get y equals 48. I won't go through solving that because that should be fairly straightforward. Now, if y is equal to 0, then that would force x to be 72. So I get 1, which says x is 72 and y is 0. That's one combination. If y is 48, and again, I'm just going back to using this equation. So if y is 48, 72 minus 48 means x would be 24. One of these pairs should give a maximum. I know, by the way, it gives a maximum because of the way this looks. I could also utilize the second derivative. The second derivative here of v would equal to 288 minus 12y. So you can see that when you plug in 0, if I plug in 0, I'd get a positive number. That means if I plug in 0, I'm concave up. Again, this is y equals 0. If I plug in y equals 48 into the second derivative, 288 minus 12 times 48 gives me a negative 288. So if I plug in 48, we're concave down. So if I'm looking for a maximum, I'm looking for this pair, and this pair is not going to work. This pair would give me a minimum. So in order to get a maximum, I use x equals 24 and y equals 48. So in the case that we're going into, v is maximized when x is 24 and y is 48. I haven't yet found the maximum value for v. The maximum value of v is going to be what we get when we take our original equation with v in it and we plug in 24 into the x variable and plug in 48 into the y variable. When we do that, 2 times 24 times 48 squared gives me 110,592. So 110,592. Maximum value of v is 110,592, and that happens when x is 24 and y is 48. This gives a good example of how maximization or minimization works. I have a certain function I want to maximize or minimize. I have some constraints. I substitute out and then utilize calculus to end up getting my maximum or my minimum. That's how to utilize optimization. At this point, I'd like you to try a problem. Push pause on the video, try it yourself, and then on the next video, I will explain how this problem is done.